Hello everyone. So let's have a look at the question one. So unfortunately, tutorial sessions we have lots of questions and we have only 1 hour. If I were in engineering department, I would have like 2 hours for 3 questions. So I need your concentration. So question one, we are asked about the existence and uniqueness of the ODEs. So the ODEs, as you see that they are y prime equal f of x, y. So we are focusing on these things, and we will like solve these analytically and numerically, these types of ODEs. Now, part A, y prime 3 times y minus 1 power 2 over 3. So let's have a look at we've got 3 theorems regarding the existence and uniqueness. And the Picard's theorem, as you see that, the y prime f of xy, the f part, it should be continuous on the neighborhood of the initial value condition point. It means x0 and y0. And also the derivative of the f in terms of y, just y, it should be continuous as well in the some neighborhood including x0 and y0. Now, part A, y prime f equal to this one, 3 times y minus 1. The initial condition is the point 0 and 1. It means here, 0 and 1. So it's been written like rectangle, and it's also written centered on x0, y0. For me, it's ambiguous. Like it's a disk or rectangle. So that's why I prefer to use the word neighborhood around that. Now, f of xy, you see that 3 times y minus 1. So in other words, it means this, if I write in the square root way, so it is, as you see that, it's continuous everywhere. So y can be, so y, we've got the exponent 2 even numbers, so y can be anything. So it's continuous, but partial derivative of the f in terms of the y has this condition. Okay, so when we are in the denominator, we have some problems. So number one, y can't be less than so y minus 1 can't be negative, and y equal 1 can't be continuous. So it's not continuous at y equal 1 and x equal 0. So x equals 0 means any point. So we can use the Picard's theorem. So we can apply it. Lipschitz condition. So Lipschitz condition means it's you see this part. This means f is continuous in terms of y. But it's a very hard condition. Not only it is continuous, but it is also uniform continuous. And more than that, it's Lipschitz. Okay, so we've got Lipschitz condition, bigger than that. Uniformly continuous, bigger than that, continuous. So but instead we don't need to have partial derivative of f in f to be a continuous in terms of y. So this theorem is also gives the not only existence but also uniqueness. Now let's assume, let's analyze that part A, question 1, if we are able to use this theorem. Second theorem, okay, Picard theorem. Picard-Lindelof, Lipschitz. Third one will be the Peano's theorem. So if I want to analyze this one. So I start from writing the left hand side. So f of this x y1 y2. So I will get this one. So I would choose y1. So y1 and y2, anything around neighborhood of the y, like y, the neighborhood of the 0 and 1. So y can be in the neighborhood of the 1. So I will choose y1 to be little bit more than 1. y2, I will choose the y equal 1 itself. So the left hand side will be like this. This expression will be 0 because if I sub y2 equal 1, this will be 0. Now let's assume that this is a Lipschitz. This f is Lipschitz. Okay, it has Lipschitz condition. So fxy is this one. So this part will have less than k times y minus 1. Any question? So when I have this one, this part, so I can divide everything by y minus 1. So I will have this fraction here. Therefore, this y1 is, this fraction is okay for every y1. I would tend or approach y1 to 1. So this will be limit of this fraction will be less than k. But what's this? What's this fraction? This is nothing, just only the definition of the derivative of f in terms of y around 1. Okay, so this implies that the derivative of f in terms of y is bounded. Okay, it means this one. Okay, at y equal 1. But we saw that partial derivative of f in terms of y, it was like 3 over y minus 1 to the 1 over 3. And when I sub or y approach y to 1, partial derivative will be infinity. So this fraction will approach to the infinity, 3 divided by 0. So this is a contradiction by what we claimed here, okay, or here. So this means f of xy is not Lipschitz at y equal 1, okay, at least y equal 1. We saw that it's not Lipschitz. So we can't use this theorem as well. So Peano's theorem, easier condition, but it gives me just about information about the existence. Existence is better than nothing, not knowing anything about that. So we can start coding up the y prime equal f to obtain at least one solution. All right, so we see that f is continuous at this point and around that. So according to the Peano's theorem, I will this y prime with this initial condition, it has a solution, but it's not unique. Okay, so let's we don't know about whether if it is unique or not. So y prime equal to this one, that's separable, so I can integrate both sides of the equation. So I will get this one. I'm a little bit sensitive. I will multiply every ODE, both sides of the ODE by 3, then power to 3. So I will have y equal to this one. Now, since y of 0 equal 1, we have the initial condition. So I'm able to obtain the value of c. So c is 0. So the solution, so if I sub here, so the solution will be y equal 27x cubed plus 1. So you would say that, okay, x equals 0, it will be y equal 1. Yes, that's right. It satisfies the initial condition. But back to the original ODE here. Okay, so you see that not only for x equals 0, but also for every x, this equation has got another solution, and it is y equal 1. And as we discussed last week, it is equilibrium solution. Okay, and it's important solution, y equal 1. So we've got the y equal 1 for every x, and we've got this solution y equal to this one. So y equal 1, so x belongs to every real number, y equal 1. So this is totally different. Although this one is also satisfy the initial condition. X belongs to R, especially x equals 0, y will be equal 1. So this means we don't have unique solution. Do you have a question about this? All right. Part B, y prime is this one. You see that? So x equal 1 is not like appropriate point for us. So f is not continuous at the whole space. So we can't use not only Peano's theorem, but also we can't use Picard's theorem, and also we can't use Lipschitz condition. So if we have continuous, we don't have continuous, so it's not uniformly continuous, so it's not Lipschitz. Okay. So one of the examples of that, f of x, so as we saw in the last part A, x power 3/2, it's not Lipschitz, but it is uniformly continuous at the closed space of 0 and infinity. Okay. Now, so we can't use any of them, but we can use maybe for, we can divide our real numbers, the space. So it can be two branches, minus infinity until plus 1, and 1 is not included, and the other branch, 1 to positive infinity. So we see that y prime 2yx minus 1, y of 0 equals 1. So 0, x equals 0 belongs to this space. At this space, we can use Picard's theorem. An initial condition belongs to this branch. So this part is, this OD is separable, so I can write this one. So, and also from here to here, I can write this one, half log absolute value of y equal to log absolute value of c times x minus 1. When you've got log, you can write log of that argument plus c, or you can put c here, and don't forget to write absolute value. So from here I can get this one. So y equal is this one, general solution. We don't know it is unique or not yet, but we will know that. And also from for the Picard theorem, you see that the derivative of f in terms of y is this part, 2 over x minus 1, and and f is continuous at this branch. X equal 1 is not included in this branch. Now, so x belongs to this one. F is continuous at minus infinity plus 1, of course. Initial condition belongs to this branch. Okay. I can obtain c squared, so c will be plus minus 1. But since I've got the absolute value here, I can use again initial condition, or implying that I've used absolute value. So I will choose c equal plus 1. So y equal x minus 1 squared plus minus 1, and also it's possible to obtain from the initial condition. All right, so y equal x minus 1 squared is a particular solution. There is no constant c, therefore it's a unique solution. While y equals c squared x minus 1 squared, or this one, is not unique at x belongs to plus 1 plus infinity, because I cannot determine that what the constant d is, because I don't have initial condition at this branch. Any question about this? All right. Part C, y prime is this one, and I can use Picard's theorem, and I can obtain that this is unique solution. Very easy. So It's separable, so I can separate everything, initial condition, integrating from both sides of the ODE. So I will get 10 inverse of y equal x plus c. Okay, 10 inverse of y, we don't need, if I heat by 10, I will get y equal 10 of x. When you heat by 10, you don't have to write 10 of this one plus 10 of this one plus k pi. No, you don't have to, because 10 inverse of y, it's already 1-to-1. Okay, but if it was 10 of y and heating by 10 inverse, you would have to write plus k pi on the right hand side. Y equal 10 of x, and so before heating 10, you should obtain c before this step. All right, so I used Picard's theorem. Part D, so y prime x equal y squared. So initial condition, like part B, this will be like part B. So y prime equal to f of x, xy equal to x times third of y. It is continuous when y is not less than 0. And derivative of f is continuous when y is bigger than 0. Okay, because y went to the denominator. So we can use the Picard's theorem for initial point. Where was the initial point? In the right branch. X equal 2 and y equal 1. Y equal 1, it means y is bigger than 0. So Picard's theorem will tell me that in the upper half, y bigger than 0 and x everything, it will, so the ODE will have a solution and it is unique. So y prime x times third of y, let's solve it. It's separable again. And since we've got the initial condition, I can determine c. And I see that y equal x to the 4/4 is the unique solution. But from the ODE, this one, y prime of this one, I see, you see that we have equilibrium solution again. Y equals 0 here. And it's satisfied on both sides. So y equals 0 is the equilibrium solution again. So, but so solution y prime, y equals 0. So y prime is this one, and not for, so y equals 0. Anyway, maybe I forgot to say something about here. But anyway, so y equals 0. So at this branch, 0 and infinity, we have unique solution. But when y belongs to minus infinity until 0, and 0 is included, so we don't have unique solution. We have solution, but we don't have unique solution. This minus infinity and 0 is a closed set, because 0 and positive infinity is open. So when the complement of a set is open, when a set is open, its complement will be closed and vice versa. Any question about this? So I think you have this similar questions in your assignments. All right. Question 2. It's about the y prime equal to f of xy, where f of xy is a homogeneous of degree 0. So I rearrange this one. So y prime equal minus x minus y x. So homogeneous means if I substitute x and y by lambda x or tx, then after substituting, I'm able to pull out t outside and do some simplification, and there is no t here, so I get again the same f. So putting tx ty, it doesn't make any difference. Anyway, f is homogeneous. This means f is homogeneous of degree 0. Generally speaking, f is homogeneous of degree n if I substitute big X means x1, x2, x3 until xn in n-dimension Euclidean space, or just 1x. Okay, tx will be t to the n f of x. So this means this is homogeneous of degree n. All right, the famous substitution and method for solving these types of the ODE, first order ODE, it's not linear, is to be like using u equal y over x. U equal to be y over x means y equal u times x. So y prime will be equal u prime x plus u after derivative, taking derivative in terms of x on both sides of the equation. So y prime is this one, original ODE, will be converted to this. Instead of y prime, I use this one, u prime x plus u equal to x. Instead of y, I will sub it by ux, okay? So factorizing x and canceling will give me this one, and u minus 1, cancellation of the u's, u prime x equal -1, and it will be separable. Separable means in one of the easiest ODEs that we can solve. So du minus 1 over x, u equal minus log absolute value of x. This times I prefer to put the c outside here. Instead of u, y over x equal to this one. This is enough. This solution is enough for me, but it is beautiful to write as your solution as possible as explicitly. Y explicitly means y equal stuff. So you can put numbers in your stuff and get your y. So y will be equal after timesing by x. It will be this one, explicit version. Or when I was here, I would put c here. So y equal minus x log c absolute value of x, which is the same as this one. So this one is the same as this one. Okay. So now let's go to the solving ODE. So x squared plus 2y squared, I see that this is of degree 2, xy together is degree 2. So I see that x squared, so xy degree 2, rearranging will give me dx over dy, xy this one, homogeneous. If f is homogeneous, reciprocal of f is also homogeneous. So I will put u equal y over x, or you can put u equal x over y. Doesn't matter. So, y prime equal u prime x plus u. In fact, I missed to see this one at first, so I rewrote it again here. Y prime equal x squared. I inverted the fraction. So instead of y prime again, this u prime plus u. So x squared here. Instead of y, I will put u times x. Then I will factorize x squared. So x squared comes outside. And instead of this y, I can write ux. So there will be another x squared here. I can simplify and I can get this fraction. So I can move this u to here, do some simplification, and u prime x will be equal to 1 plus u squared over u. Again, separable. So this substitution, change of variable method, will move you in the homogeneous ODEs to a separable ODEs. So then after it is easy to solve it. U over 1 plus u squared So it is obvious that why I did 1/2 and 2 here, I don't need to explain it to you. So from here, 1/2, do you have question? It is easy to integrate it for me. 1/2 absolute value of x. So I will get this one 1/u squared plus I hit by exponential both sides of the equation, c squared x squared. So instead of u, y/x, I use initial condition to obtain c squared 2. So y plus 1, this one equal to x squared. So x squared, y squared. So y squared is this one. And as possible as we can get explicit solution. Plus minus 1, plus minus x times third of this one. I can obtain that which one should I get by using initial condition. So I have to choose minus. So y equal minus times stuff will be my solution. Do you have a question?
How do you know to choose minus?
Okay, so this, you see this one? Let's apply, let's put x equal minus 1 here. So this will be 2. 2 times minus 1 squared here. And this will be 2 times 1 minus 1. It will be 1 third of 1. So minus 1 plus minus 1. So then I have to 1 minus 1. And I have to choose minus. So minus will be plus 1 to get this one.
Oh, I can get that one.
Yeah. So this one, Bernoulli. So in your mid-semester example, you will have one question about the Bernoulli. So I promise that you will have one question about Bernoulli and it has 3 marks. So y prime of this one, it's been given in the way that we want. So I distribute y inside parentheses, xy to the 4 minus y. So y prime, so I move this minus y to the left by changing the sign, x times y4. Generally speaking, Bernoulli's ODE is like y prime plus pxy equal qx, y to the n. If this y to the n wasn't here, this ODE would be first order linear equation. So what do we do for these things? You don't have to think too much. You don't have to memorize anything else because you know first order ODE and how to solve it. And you know taking derivative is also is your skill. So by just memorizing this, what do we do is this substitution. U equal y to the 1 minus n. Y to the 1 minus n is coming from here. Just remember this part. The rest is okay. So the process is this. So you have this one. You need to sub it y prime. You need to do so for to be able to do this. Let's take derivative from both sides of the equation, this part. So u prime will be minus 3, y prime, y to the 4. So this part, you see this part. Let's put y prime to be here, comes here. Okay. So this part, you see, y prime has been multiplied by this green highlights, minus 3 times y to the minus 4. So I will, do you see this star here, star? So I will multiply the star by minus 3 times y to the minus 4. Again, I'm telling you that you don't have to memorize everything. If you write you will then discover that what you want to multiply it. So I will multiply this star by this highlighted green. So I will get this one, get this one, get this one. Why do we want to do this? Because if I multiply by this y prime, this whole thing's first expression will be u prime. U prime. Then the rest will be fine. If you do everything right and carefully, you will see the cancellations. So for example, y to the minus 4, and I had the y to the 4 here, so they will cancel each other. And y to the minus 4, so it will give me y to the minus 3, and it is u. So u prime minus 3u equal minus 3x. And the rest is easy because it's first order linear, ODE. I of x, exponential of multiplication of this u, minus 3. So e to the minus 3x, integrating factor. So then I will hit this equation from the left. From the left, it means on both sides, but from here. So this will, u prime will be this one, this will be this one. So the green highlighted can be written as one expression here. I shouldn't say these things because you have learned this from 1120 equal to this. And then I should integrate from both sides of this equation. So then I will get this one, then I will get minus 3. Integral of x times e to the minus 3x. How was I able to get this? What did I do here? Integrating by parts. Do you agree? So let's write a small remark here. Integral of a polynomial x times exponential of alpha x sine x cos x, maybe sine x, cos x dx. I have to use integrating by parts several times. Integrating by parts several times. So if it's x power 1, so you will use just one time by parts. If it is x power 2, you have to use twice integral by parts, integrating by parts. So dividing everything e to the minus 3x, so I will get this brownish highlight as my solution. So wait, so I should sub back u by y to the minus 1 minus 4. Y to this one, and I can get this one. This is my solution. Do you have question about this, Bernoulli? Question 5 is again Bernoulli, y prime. I'm rearranging this part, so I will get this one. Okay. And again, u equal y1 minus n. What is my n? N is not natural number necessarily. It's a minus half. So I will get y to the 3 over 2. Then I can hit this u prime. I get derivative of both sides of this. So u prime of this green to y prime. So I will multiply this star brown by this. 3 over 2 y to the 3 over 2 minus 1, which is half. So if I multiply this one, this part, first expression will be just u prime, and the rest will cancel, and u prime is, so then we will get this first order linear ODE. So one Bernoulli question. Do you have question, Bernoulli? Okay. And you will have one question about Riccati. And this will happen in your like mid-semester exam. So your job, 50% of job to be able to solve the ODEs analytically, it's 50% is about to be able to distinguish that what the hell it is. Okay, sorry, what the ODE is. Okay, so I sometimes lose my speech. And this means distinguishing, determining of the method is important. Now, so Riccati is the one of that. The explanation here is not nice, to be honest. So Riccati has got this one. In Sage Math also there's a DE solve function has the argument that you should, I don't know, I don't remember. You should add something to be able to solve the Riccati's type equations. It's like this. If Qx was 0, this would be Bernoulli. Okay, so I could have this one. Now, what do we do then? So in these types of, so you've got two methods. It depends on our laziness condition. If the rate of the laziness is high, what you wanna do is this one. You will be given a particular solution, or maybe it is easy to obtain one solution. Y1 is this one. Particular means like one solution, any. It doesn't have any special feature. Y1 is this one. So let's assume that Y1 is this one for this green highlight. So what do we wanna do? One way, if we are too lazy, we will do this change of variable. Instead of y, you will put y1 plus u. Then we will this generally, or this one will be a Bernoulli ODE. But if we are a nice person, we can use this substitution. Instead of y, you should sub by y1 plus 1 over u. Then we will, so the derivative will be hard, 1 over u. We've got the fraction. But instead, with some difficulty, instead of reaching to the Bernoulli, we will reach to the first order linear ODE. So then everything, then after that, everything that you know what to do. So part A, let's do some analysis. So I've got this one and I wanna use one of these. So y prime is this one, and let's assume that we use the first method. We wanna reach to the Bernoulli. Instead of y, this one, I wanna put y1 plus u. What the y1 is this. If I sub y1 here, then y1 will be equal px qx y1 rx y1 squared. So now y, as usual, I will take derivative from both sides of the equation. So the general form of the Riccati will be y1 prime plus u prime, px, qx, and these things. If I simply expand these things, okay, this line and this line. Do you see the red highlighted color? Only reds. Y1 prime, I'm able to cancel these because have a look at here again, red highlight. The reason is here. Y1 is the a solution of the Riccati. So y1 prime is this one. So that's why I can use two equal things from both sides of the equation. So we have been left is these things. U prime equal this dark highlight. I move them to the left-hand side and it will be like this. I will factorize u as well. So Rx is u. So what is this is just u prime plus or minus something times u, something in terms of x times u equals something else in terms of x to u power 2. So it is Bernoulli And the Bernoulli is u power n 2. So the change of variable w will be u power 1 minus n or 1 minus 2. So w will be u inverse. So then after you will start solving this equation and w prime will be this one. So this u squared will be deleted from here. So you can read this one, read the rest easily. All right, so let's assume that you are given a Riccati equation. Are you able to use this general formula to solve your equation? No. If you do like this, then you won't get graded. What you want to do is this one. Just forget what I said about the general solution. It's like y equal, so let's assume a part B here. So this one, we don't need to memorize the cheat sheet, like you don't, so just learn the process. Y1 2 over x is given to us. So I will use this one, but you can use y1 plus u instead. But let's jump into the first order linear. Instead of y, I will put y1 plus 1 over u. So y1 is 2 over x plus 1 over u. So as usual, I will take derivative on both sides of the equation. So I will sub y by 2 over x plus 1 over u at the original ODE here. So instead of this one, instead of this y, and y prime will be subbed like by this. Now, so this pop-ups, you see this one here, minus 4 over x squared. Okay, this one. So minus 4 over x squared. We've got 2 over x and nothing. Minus together, this will be minus 6 over x squared. And this orange highlight will be 4 over x squared. I can expand this one. So these together, 4 over x squared minus 6, it will be minus 2. And these will, green circles will cancel each other. So what will I have is this minus u prime over u2. Again, this one and this one will be 3, 1 over u squared. So I will multiply everything by minus u squared. So I will get this. This is first order linear ODE. Okay, so what you wanna need to memorize really from Riccati is this, from this part. The rest will come automatically. So the rest is like first order linear. Integrating factor will be exponential of integral of integral of this one, ix, absolute value of x to the 3. So I can choose positive x to the 3 or minus x to the 3. Okay, it's up to us. So I will choose this x cubed. So I hit everything by x cubed, so then I will reach. So if you are able to choose minus x cubed, so you can reach this one. Both of them will work. So from here, these two expressions can be written as using product rule. It will be like this. Then you can get this. Then instead of u, so u will be this. Then instead of but remember that y was this 2 over x plus 1 over u. So instead of u, you can put this one. And then after you can obtain the rest. But what we have, let's assume that we were lazy. So instead of our start wasn't good. Let's start that instead of instead of 1 over u, you can just use u. What will happen is this one. Where are you? Okay, here. To y1 plus u. So I will have y prime, then I will sub everything this one, substitution. then u prime minus 3u over x will be equal to u squared. So this u squared is, it means Bernoulli. So Bernoulli, then you know what to do the rest. So the rest will be w u power what? 1 minus 2. Yes, that's enough. So then the rest will come automatically. Question 7, you will have one question about, so Bernoulli, one Riccati, and one long non-perfect ODE. These three questions. So it will have 5 grades, I think, I remember. So let's assume that xy dx, this one, coefficient of dy. I would call the coefficient of dy as n, the coefficient of dx as m, okay? You can have your own formula for these types of ODEs. So m, n, so equals 0, nothing interesting here. I will take derivative of the coefficient of dy, which I call it n, in terms of x, which will be equal for x. M sub y will be x, because you see x, y. If I take derivative from here in terms of y, it will be just x. I will constitute nx minus my equal to 3x. Then I will start to decide that which one is easy. 3x divided by m or minus n. Which one will happen? We will see that. We can see that m is easy. So mu y will be divided by n, dy. So in your cheat sheet, please write these things. Mu y or mu x to divide it to what? Like what type of? Which one you should divide it? And it will be in terms of y or x. Your notation might be different than lecture notes. So you just write something for yourself. Okay, exponential mu y exponential. So 3x, if m was xy, so this will be absolute value of y to the 3. For the same reason, I can choose y to the 3, but we could choose minus y as well. So I can multiply everything by y cubed xy dx plus this dy equals 0. So let's assume that this f, we solve this one. What would be the answer? The answer will be f xy equals c. If I take differentiation in terms of x, okay, this will be del f over del x from 11 to 20. It's like this, okay. Complete total differentiation means in terms of both of them, so it will be like this. So this means this part is m, this part is n. So del f over del x is del f over del x equal x times y to the 4. Complete differentiation or total differentiation, maybe you haven't studied, but it's not important. It's like what I say is like this. df is equal to this one. Differentiation of c is 0. It's clear. So del f over del x, it was a nu m. What nu m is after multiplying by the integrating factor. This one. xy4. I will take integration in terms of x. So this one plus gy. Gy is my constant because y can be treated in this integral as constant. So del f over del y, like this one, what? Okay, I've got this one here, and I will take derivative in terms of y. So I will get this one. The right hand side of this one will be this. But what was del f or del y? It was like this one. This one, I can expand it, and I will see some cancellations definitely. Otherwise, it won't be good. So G prime Y. So when you integrate, so you will take antiderivative or integration from here. So don't put C here. So Gy. So now you got F equal this part plus this part. Then you can easily put equal C. Easy. Now, let's assume that part. Do you have question about this? All right. Let me look up something for you. Just 1 minute. Okay, so part B is the perfect ODE. So you will use the same process here, this one. Do you remember that from Math2800, you were asking that find the potential function. Gradient of little f will be capitalized F. The capitalized F has been given to you. So you were asking to get the little f. It's like the same process. Over there, it was like 3 variables. This one is like 2 variables, and this means it is easier. So part B is the same thing. Other method. So if you use 5x plus 4y, it's part B. So since it's perfect ODE already, so you see this one, the coefficient of m is 5 over 2x squared plus 4xy. Integral of this one dy is 4xy minus. So I will choose one of the repeated things, one of that. Then I will get one this and minus this one and put equal c. Easy. But if you use this method, you won't get graded. Okay. So I'm sorry about that. So again, integrating factor part C, you see this part C. So I see my, nx. So what I will, the strategy is this, nx, my. So you see minus 2y. Then you will have a look at the formula here, m and n. You will decide to divide it by m or minus n. Okay. So I decided by divided minus n because minus 2y to the easy one here. So mu of x exponential minus n. Minus n is minus 2xy. Exponential of absolute value of x. So I can choose mu x equal to x. But I could choose minus x as well. So then again, this ODE and multiply everything by x. So del f over del x is this one, is x times this, and del f over del y is this one, and so on. Question 8 is the same thing, and I have written it here completely. It's just the same perfect ODE, so it's just the IVP version. It's got initial value condition. I hope you learned today something. And it's your, as I said, determining what method you should use in your mid-semester exam, which will happen in week 7 on Wednesday 8 a.m. I'm sorry, it's very hard. Yeah. And it will be stressed condition. You should be sharp and fast. All right. Have a look at day ahead.